Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 2 paper from summer 2023. This paper is worth 120 marks in total, and this is the fourth video of 6. It will focus on questions 13 to 16, which account for 20 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 13. Ken measured the resting heart rate in beats per minute of 12 people. He asked them how many hours of exercise they usually completed each week. The results for 7 of the people have been plotted on the scatter diagram. So we've got this scatter diagram here. Resting heart rate and then hours of exercise per week. Part A. Here are the results for the remaining 5 people. Plot these results on the scatter diagram. So we're going to plot these results onto this graph. So hours of exercise per week was along the bottom. So I'm going 2 along and then 70 up. So 2 along up to 70. That's the first person. 4 along up to 58. So 4 and up to 55, 6, 7, 8. 1 along and then up to 60. 1 up to 60. 7 along up to 55, so 7, 50, 55. Make sure you pay careful attention to that scale. And then 5.5 along to 57. So we've got 5, 5.5, and then going up to 55, 6, 7. So 1, 2, 3, 4, 5. We've plotted those remaining 5 parts. Part B. Ken recorded one person's resting heart rate incorrectly. Circle the point on the scatter diagram that this is most likely to be. So if it's been recorded incorrectly, it's likely to be an outlier that's not following the trend of the data. So this point here is not following the trend of the rest of the data. It's too far away, so that would be our outlier here for part B. C. Describe the relationship between hours of exercise per week and resting heart rate of the people Ken asked. Ignore the result that was recorded incorrectly. So it wants us to describe. So we're not going to use any numbers here. We're just going to describe what we can see from the graph. Okay. So the higher the resting heart rate, the lower the hours of exercise, because that's the highest resting heart rate, but they've done the least amount of exercise. And then if we look across here, as the hours of exercise increases, the resting heart rate decreases. And that's what we'd expect sensibly, because the fitter we are, the more we exercise, the lower our resting heart rate is. So the higher the more hours of exercise per week, the lower the resting heart rate. So that's what I'm going to write here. The more hours of exercise per week, the higher, oh, that's not what I said, the lower the resting heart rate. You could also say the opposite. You could say the lower the heart rate, the less hours of exercise per week. 14A. Geomet High School has 740 students. Each student was asked which method of travel listed below was their main method of travel to school. The table below shows the methods of travel together with some of their probabilities. So we're working with probabilities here. So we've got method of travel, walk, bus, bike, car, train or other, and then the probabilities here. And what we have to remember is that the probabilities add to 1. So all of these here will total 1. Part 1. A student is chosen at random What is the probability that this student walks to school or travels to school by bus? Okay, so the probability that they walk is 0.2 and the probability that they travel to school by bus is 0.35. So we're going to add those together, 0.2, 0.35, which is 0.55 as a probability. We're working in decimals, so we're going to stay in decimals for our answers. How many of the 740 students travel to school by bus? Okay, so there are 740 students in total, and the probability that they travelled by bus is 0.35. So if we do 740 times 0.35, that gives us 259 students that travel to school by bus. Part 3. The probability that a student travels to school by car is twice the probability that a student travels to school by train. Calculate the probability that a student travels to school by train. So this is looking at the blanks in that table up there. And if you remember, I made that note to myself that these probabilities must add up to 1. So the first thing I'm going to do is I'm going to add up the probabilities that I know. So 0.2 plus 0.35 plus 0.3 plus 0, but I'm not going to pop that into my sum because it makes no difference to the answer. So 0.85. This has all got to add to 1 because probabilities are between 0 and 1. So if I take that probability away, 0.15 needs to be split between car and train. Now it tells us here, travelling to school by car has twice the probability. So this is going to be 2 lots and this is going to be 1 lot of this 15. So I'm going to split this into 3. So 0.15 divided by 3 equals 0.05. So 2 lots of that would be travelling to school by car, and then 1 lot of that would be travelling to school by train, because this is 2 lots and this is 1 lot. So this is the probability that they travel to school by train. I'm just going to make that nice and clear. Part B. The Venn diagram shows information about the number of students who study music and drama in Year 11 at GMET High School. So we've got this Venn diagram, we've got the 2 overlapping circles. Music is this circle here, drama is this circle here, and we've already got some values filled in. There are 104 students in Year 11. Complete the Venn diagram to show the number of students in Year 11 who do not study music or drama. So the fact that they do not study music or drama puts them here on the outside of that Venn diagram. So let's see how many of that 104 we've got so far. So we're going to do 17, add 14, add 11. Simply the numbers in the Venn diagram there. 17 plus 14 plus 11. Now I'm writing this out, remember, because it's a calculator paper and working out is also appropriate to get me marks if I do go slightly wrong somewhere. So there's 42 already out of those 104. So if I take 42 away from 104, that tells me that 62 do not study music or drama. Oh, that goes up there. My bad. Easy mistake to make. Okay. Part B. The Venn diagram shows information about the number of students who study music and drama in Year 11 at GMET High School. So we've got this Venn diagram here, 2 overlapping circles. Music is this part of the Venn diagram, drama is this part. There are 104 students in Year 11. Complete the Venn diagram to show the number of students in Year 11 who do not study music or drama. So the do not study music or drama would fall on this line here outside the Venn diagram, not inside. So we know there are 104 students in total. These are the number of students that have already been taken into account. So we're going to subtract these from 104. So 104 subtract 17, 14 and 11. which leaves us with 62. So 62 would be completed on the outside of the diagram. That those are the students in Year 11 who do not study music or drama. What is the probability that a student chosen at random from Year 11 studies music? Okay, so random from Year 11 means we're taking them out of the whole Year 11 cohort. There are 104 students in total in Year 11. So I'm going to pop 104 on the bottom of my fraction for my probability. So studying music. This is the circle for studying music. So the 17 and the 14 are all students that study music. Now this 17 only study music, this 14 study music and drama. However, it doesn't specify only music, it just says music in general. So we're going to include both of these on the numerator of our fraction. 17 plus 14 is 31 out of 104 is the probability that a student chosen at random from Year 11 studies music. Question 15. A shop sells storage boxes. A stack of 4 of these boxes is shown below. So we've got a stack of 4 boxes, and it gives us the height of one box and the height of all 4 boxes. The height of a single box is 35.2 centimetres, which they've labelled on the diagram for us. The height of 4 of the same boxes when stacked is 52 centimetres, which is also on the diagram for us here. A different stack of these boxes has a height of 85.6 centimetres. How many boxes are in this stack? So the important thing to notice here is that the boxes stack inside each other. So it's not simply a case of having one box on top of another. It's this lip here, look, that's on the top. So we need to figure out what the size of that lip is, okay? So we know from here to here is one full box, including its lip, that's 35.2 centimetres. So from here to here is 1, 2, 3 of those lips of the box. Now this whole height from the base of this first box all the way up to top is 52. So the difference between these two heights is equal to these 3 lips here. So I'm going to take the heights away from each other to start off with. So 16.8, so that is equal to 1, 2, 3 lips. So let's find out how much one lip of a box is. So I'm going to divide that by 3. So 5.6. So these are all still in centimetres. So each one of these is 5.6, okay? So we've got a different stack of these boxes with a height of 85.6 centimetres. Now we know that the height of the bottom box is going to be 35.2. It's the same boxes. So I'm going to start by taking 35.2 from the total height of this new stack. 50.4. So this 50.4 must be made up of lips of boxes because they fit into each other. So I need to see how many of these 5.6s fit into 50.4. Nine. So there are 9 lips in this new stack on top of that first box. So we have 9 plus 1, which tells us there are 10 boxes in that new stack. Question 16. Make G the subject of the formula. So we're going to rearrange this formula so that it says G equals instead of H equals. And we're going to do this using inverse operations. So the first thing I'm going to do is I'm going to move the K. So I don't want this K to be here. Now there's no sign in front of it, so it tells me it's positive K. The opposite of a positive K would be a negative K. So I'm going to start by subtracting K from both sides. So when I subtract K from the left-hand side, it's H subtract K. I simply write it because I don't know the value of H and K, so I can't calculate it. And then when I subtract k from this side, it eliminates k and leaves me with 2g. I'm aiming to get g on its own here. It doesn't matter which side the subject is on, so I'm okay with g being on the right hand side. The next thing I need to do is I want it to be equal to 1g. At the moment I've got 2g, 2 times g. The opposite of timesing by 2 would be to divide by 2. So when I divide by 2, it gives me g on the right hand side, but this is where you need to be careful. When you divide by 2 on the left hand side, you need to divide everything by 2, so you need to write it as a fraction. And there you have it. You've written g as the subject of the formula.